Well, welcome back, everyone. And today we are doing exercise 2D. Once again, this exercise is super short, so I'm in a good mood today. We're switching to a darker color since my eyes are starting to hurt. Okay, looks like we're getting into square root functions here in the domain and ranges of these. So let's just go ahead and start by writing this one out. Okay, one rule we need to remember for square root functions is that inside of the function, if we want real solutions at least, cannot be uh, less than 0. It has to be greater than or equal to 0. So that can help us find out the domain and range of these functions. So let's just start with the domain. Usually what we've always been doing is just saying that it's going to be equal to all real numbers, then set some boundaries. And remember what we said, the inside of this function has to be has to be greater than or equal to 0. So that means we can set up an equation like this, which means that x is going to be greater than or equal to 2. And that is our domain. Okay. Likewise with our range, since we have nothing like on the outside of this radical being added to it, and we know that the inside can only be either 0 or positive numbers, that means the greatest number it can be is going to be 0, and that is our solution. On to 2, we have y is equal to square root of 3x minus 2. Let's actually start with our range on this one, since it's just going to be pretty easy. Remember, range is going to be an element of all real numbers such that y is going to be greater than or equal to 0. Once again, since we only have a function on the inside of this radical, the smallest number this inside can be is 0, and the square root of 0 is 0. Our domain, on the other hand, is going to be equal to all real numbers such that x is greater than or equal to, and then let's solve for that. We can set up the equation 3x minus 2 is equal to 0 to get the x, not equal to 0, but less than or equal to 0, or greater than or equal to 0. So then we get x is going to have to be greater than or equal to 2/3 for this function to be real. Okay, on to number 3. Number 3 switches it up a bit. It says y is equal to 1 plus the square root of 2 minus 4x. This time we're going to start with our domain. Remember, domain is equal to all real numbers such that this inside does not equal 0, so 2 minus 4x is going to be greater than 0, or greater than or equal to 0. So then we can set up an equation like this, where we get 2 is going to be less than 2 is going to be greater than or equal than 4x. X is going to be less than or equal to 2. So then we can set it up like this. Let me just make sure I wrote that right real quick. Did I say 2? Whoa. 1 divided by 2. Sorry. Did my math wrong for a second. Everything's right. Yep, okay. In our range, remember, we're going to set it up like this, then find the boundaries. Remember what we've been saying this entire time, that most of the time, if there's only a function inside of this radical, the range is going to be all real numbers such that y is greater than or equal to 0. However, we do have a 1 on the outside now, so even we have another function on the outside now, is what I should say, that is not radicalized. So even if our inside is our lowest number 0, it's going to have a plus 1 to it every single time, so that means we know our range has to be greater than or equal to 1, and that is our answer. Okay, on to number 4. Well, I guess I'm marking these as like 1, 2, 3, 4. They're not technically that. They're 1b, c, d, and this is going to be 1d. So I'll start doing that. We have y is equal to 3 minus the square root of 2x plus 1. All right. Let's see. Let me think about this real quick. Okay. So let's go ahead and start with our domain. Domain is going to be equal to all real numbers such that when x is, or 2x plus, let me like make some space while I'm writing this. 2x plus 1 greater than or equal to 0. X is less than or equal to negative 1/2. Did I write this wrong? No. Oh, yeah, I did. Shoot. Yeah, my mistake. It's when you divide x by a negative, not just minus. Okay. X is going to be greater than or equal to negative 1/2. And then for our range is going to be equal to all real numbers such that, remembering what we said last time, even if this inside is equal to 0, that's going to be 3 minus 0, which means that y has to be greater than or equal to 3. Just make sure that's true. Yeah, okay. On to 1e. Hold up, sorry, I need to check something real quick. Just give me a second, everyone. Hold up, this is I just need to make sure of something before we go on. Okay, I'm not going insane. Good to know. Okay, just checking something. Next equation is y is equal to negative 2 times x minus 1. Okay, switch it up a bit. We're just going to continue to do the thing we've done every single time for the domain. Domain is equal to all real numbers such that x has to be greater than or equal to 1 in this case. Since if it's under 1, it's going to be a negative number. But now our range, there is 2 functions still here, negative 2, but it's being multiplied. So even if this equals our lowest number here, it's just going to be 2 times 0, which is going to be equal to 0. So we know y has to be, oh wait, no, whoa. I was about to say greater than or equal to 0, but it's actually going to be less than or equal to 0. The reason being is this can only compute positive numbers or 0. If it computes 0, it's equal to 0. If it computes a positive number, it'll be negative because of that negative 2 on the outside. So this is our final answer here. Okay, on to the next one and the last one, 1f. If y is equal to 1 minus 3 square root of 2 minus x. Starting with our domain, since that's the easiest part of everything usually. X has to be greater than or no. X has to be less than or equal to 2. When it's greater than 2, this will end up being a negative number. When it's less than, it'll be a positive. And when it's equal to 2, it'll be 0. And for our range, once again, real numbers such that, alright, looking here, as we said earlier, remember our function back here that was negative. We learned that if we just have this part here, then our range has to be less than 0 since we're getting multiplied by a -3. However, let's take in the case scenario where this inside function becomes 0. So now we're going to have 1 minus 3 times 0. And guess what? That's 1. So our highest number is going to end up being 1. So y has to be less than or equal to 1 here. And that is our final solution. Hope you all enjoyed today's video, and I should probably get to sleep soon. Have a good night.